back again to our mathematics class. For today, we are talking on graphical method of solving simultaneous linear equation. In our last class, we solved simultaneous linear equation using elimination method and substitution method. Now, I want to solve using graphical method. When you hear of graphical method, it means that all the solution will be done in your graph. Now, to solve simultaneous linear equation graphically, you have example 1 on the board. Solve x plus y equal to 10 and x minus y equal to 2. Graphically, using the values of x from -2 to 6, and your scale has been given to you. What do? The first thing you do is to name the equation. I have x plus y equal to 10, equation 1. I have x minus y equal to 2, equation 2. Now, to solve graphically, on your graph you have just x and y axis. You have just x and y axis. So what do? Make sure that the equations given to you is having y as a subject of the formula. Therefore, I have from equation 1, make y the subject of the formula. If y should stand on its own, you have 10 plus x leaves y, crosses over, becomes minus x. I have equation 1a from equation 1. Y is the subject. From equation 2, y is negative in the equation 2. I want it to be positive, so I'm moving it this way. Minus y crosses over, becomes plus y. Therefore, I'm taking 2 over to this way. I have minus 2. So minus y moves this way, plus 2 moves this way. I have equation 2a. So I succeeded in making y the subject of the formula in both equations. The next thing you do is to make table of value for 1a and 2a. Table of value for 1a. Remember, we are giving values of x from -2 to 6. Values of x from -2 to 6. So I have table for 1. Table for 1. I have the first row and the last row. The first row is always your x. The last row is always your y. I have -2 to 6. So the numbers, according to your number line, -2, the next one is -1. I have 0, 1, 2, 3, 4, 5, and 6. What happens to this space? The equation for 1a says y is equal to 10 minus x. So I have 10 minus x is equal to y. So all the terms in the equation will be shown on the table. The first term there is 10. This is my 10. The second term there is minus x. This is my minus x. It is equal to y. So the first term, 10, does not have any x, does not have any variable. What happens to it on the table? It appears the same way along the columns. You see it that way because there is no variable, a constant. The first minus x, the first x is -2. So minus x, when x is -2, becomes -2. Minus in the x, then when it is -2, you have another -2. So minus times minus is plus. So the first x value there is 2. So I have 2. The same thing, do the same thing for the second value of x. You have -1. Minus times minus is plus. You have +1. So we continue that way. You are having 0 here. Minus x is -1, -1. Minus x is -2. When x is 3, you have -3. When x is 4, you have -4. When x is 5, you have -5 and -6. What is your first value of y? You work with this. 10 plus 2 is 12. 10 plus 1 is 11. 10 plus 0 is 10. 10 minus 1 is 9. 10 minus 2 is 8. 10 minus 3 you have 7. 10 minus 4, 6. 10 minus 5, 5. 10 minus 6 is 4. Table 1. We are done with table 1. We move to table 2. Table of values for 2a. The range of x still remains the same values of x. So I have the table, I have the first column, the first row for x, and the last row for y. I have minus 2, minus 1, 0, 1, 2, 3, 4, 5, and 6. So from equation 2a, the first term there is x. The second term is minus 2. So I have x. The first is x. The second is minus 2. Don't confuse yourself with the 2x. It's still the same. So all I need to do is to bring down these values for the x. Or you can decide to use this and just have x minus 2 and y. But let me do it this way. Minus 2 constant without x remains the same. You bring it along in the same way. Minus 2 all 2. First value of y is minus 2 minus 2 is minus 4. You are owing 2, you're owing 2, you're owing 4. Minus 2 minus 1 is minus 3. 0 minus 2 is minus 2. 1 minus 2, you are still owing 1, minus 1. 2 minus 2 is 0. 3 minus 2, 1. 4 minus 2, 2. 5 minus 2, 3. 6 minus 2 is 4. Table 2. So we have to plot these two tables simultaneously on the same. Okay? What I have on the board is a sketch. Remember I said that it is best done on a graph. Now from the equation we are given 2 cm to 1 unit on x-axis, 2 cm to 2 units on y-axis, and this is what you have as a representation. My graph is a 1 cm graph. You see the first small box, the second, this is 2 cm. For x-axis we have 1, we are counting in 1, so I have 1, 2, 3, 4, 5, 6. Why I ended at 6? Because I have just 6 there. On the negative side, I also have minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. For y-axis, 2 cm is 2 units. That is, you're counting in 2s. So you have 2, 4, 6, 8, 10, 12, 14. The same way here, 2, minus 4, minus 6, minus 8, minus 10, minus 12. If you still have space in your graph, you can fill up. So what do? We'll take the first table first. From the first table, we were told that when x is minus 2, y is 12. What do? Look for x when x is minus 2. You see minus 2 this way. This is x when it is minus 2. And you have 12 for y. So what you need to do is to connect minus 2 to 12. As I said earlier, this is just a sketch. Minus 2 to 12. So this is my point. So I have minus 1 to 11. This is minus 1 for x. Take it to where you have 11. This is my 11. After 10, I have one line before 12. So this line that I did not write anything is is 11, not minus 11. Now when x is 0, at this point, x is 0, y is 0. When x is 0, y is 10. So you move to where y is 10, you make your point. When x is 1, y is 9. This is my 9 between 8 and 10. Connect it to 1. When x is 2, y is 8. This is my 8. All these dots I'm doing in your graph, you don't do dots. Your graph has line already. When x is 3, y is 7. Between 6 and 8, you have 7. x is 4, y is 6. When x is 5, y is 5, between 6 and 4. When x is 6, y is 4. So this is my table 1. The next thing you do is to join the points. It's supposed to be a straight line. For my sketch, you manage it this way. You have a straight line. Connect the point with your ruler, transparent ruler. You are having a straight line. We'll plot the second table still on this graph. The second table I have when x is minus 2, y is minus 4. When x is minus 2, y is minus 4. So you connect minus 2 to minus 4. When x is minus 1, y is minus 3. When x is minus 1, y is minus 3. Minus 3 is between minus 2 and minus 4. This is my minus 3. When x is 0, y is minus 2. This is x 0, y is minus 2. You have minus 2 this way. When x is 1, y is minus 1. Minus 1 is between this 0 line and 2. So I have minus 1 here. I have at this point. When x is 2, this is x2, y is 0, so it's on the line. When x is 3, y is 1. You have 1 this way. When x is 4, y is 2. This is y is 2. You connect it to y, x is 4. X is 5, you have y is 3. Between 2 and 4, you have 3. When x is 6, y is 4. This is my 4. You will see it at the same point. So we connect the points with a straight line. So the two equations we have plotted on the same graph. The point of intersection of the two straight lines, line 1, line 2, point of intersection lies the solution. So at this point where the two lines intersect, that is where the solution is. At this point is the solution point. Solution point. Now you read the value of x and y. At this point, x is 6. At this point, y, you connect your line to your y is 4. So graphical method, x is 6, y is 4 for the problem. I hope with this example, you can plot or you can solve simultaneous linear equation graphically. Bye. See you in our next class.